Guys, in this last part of the lesson, we're going to do a thing called intersecting graphs, where the one graph and the other graph get romantic with each other and they touch each other. This is very romantic. So we're going to look at where we get the points of intersection. Okay, now we're going to take a line and a little bit of a hyperbola and find out what are the coordinates of the points of intersection. Remember in grade 10 they did simultaneous equations
yes,
with two lines. In grade 11, of course, you had, a line with more difficult quadratic or something very nasty. Okay, but now let's have a look at the graphical meaning of simultaneous equation. Let's have a look at example 4. Determine the coordinates of the points of intersection of the following graphs. Here's the picture. Okay, here we go. Notice there's the line x plus y minus 1 equals 0. Okay, and we've got a little bit of a xy equals 6. Guys, remember, it could have been written as y equals
negative 6 over x.
But we've got it in this form. Now, Nelson, we want to get A and B the coordinates. Notice, guys, important, listen, coordinates of the points of intersection of the two graphs. How do we approach this? Take them through it, Nelson.
Guys, the coordinates of A and B is where, at A and B, these points are where the graph of the hyperbola meets the graph of the straight line. So, if you look at this, guys, x plus y minus 1 is the straight line, and y equals negative x plus 1. What we did here, we just got y by itself. We're talking of simultaneous equations to get point A and B. We solve these two equations simultaneously, and the second graph is xy equals negative 6. Remember, this negative x plus 1 and xy equals negative 6, this is the same as the top one. We just transposed the top one together. So, we got y by itself on top here. What is the purpose? To replace, we sort of interweaving, to replace y by negative x plus 1 in the second equation. Let's have a look. What we did here, we took the second equation, which is xy equals negative 6. In place of y, we replace negative y by negative x plus 1. Have a look. This negative x plus 1 is in this place of y equals negative 6. And you multiply the brackets, you get negative x squared plus x equals negative 6. Transposing the equation, I got this negative x squared to the right, x to the right. Now, simple factorization here, x minus 3, x plus 2. Remember, when you factorize this, you have this. Now, have the values of x equals 3 or x equals negative 2.
And guys, those are the x values of the points of
Don't
intersection.
stop here.
And you don't stop there, because remember, they want the coordinates of the points of intersection. So the x values
and
would
the
be
coordinates, you must write your answer as coordinates.
Coordinate form. Right, let's go.
Have a look. These are the x values we got. We're going to use this. Anyway, you can use any equation.
You can use any one, but
look at the simple one.
The simple one, minus x plus 1, which is great. I think the other one's also easy to use, but we're going to use this one.
Yeah. For x equals negative 2, we replace x by negative 2. Have a look. You know the substitution. Y is 3 now. What about x is 3? Using the very same equation, x gets 3 and negative 3 plus 1, which is negative 2. Y equals 3, y equals negative 2. X is 3, x is negative 2. But you cannot, Mark, I think they will lose marks if they leave it like this.
Yeah, very important.
The question says find the coordinates.
And very important, because you got the graph, you've got A and B. You've got to say who's who in the zoo.
Good.
Okay.
Yes.
So, Nelson, let's put them into coordinate form, these things.
Okay. A. Why are we saying A is negative 2? What do we name this point of negative 2 for x and 3 for y? Because if you look at this, if we were to relate this or associate this with your graph, you'll find that A is on the negative side.
That's right. Yeah.
Where x is negative 2. It's a matter of associating. And B is 3 and negative 2. Look, the coordinates from x and y. X and Y. Don't leave your answers like this.
And don't forget, because what we've done is we've indicated that, and if you have a look at this, if we go back to the graph, guys, have a look here. We're going to see we've got these coordinates. Let's just have a look there. If you look at the graph, A is going to be clearly the -2 and 3, and the B is going to be 3. X is 3 minus 2. It looks right there, Nelson.
Yes.
So important that... And
even if the diagrams are not drawn to scale, but you can easily...
and don't
relate
measure with your rulers.
No.
Some people measure with it. The diagrams are not
You
to
just
scale.
get a guide.
Yeah, absolutely. And guys, don't forget concepts like domain and range. As well. They come up as well. Domain, we'll look at that in future lessons as well. Domain and range. Domain X goes
and
from
some related questions on the transformation.
Yeah, I think
worried about the transformation.
Very much in the transformation. We'll do a lot of that in the lessons in the future. But watch out, domain, smallest x to biggest x, y, smallest y to biggest y. But we'll come on to that. I don't know about you, Nelson, enjoy this part of the syllabus. It's really exciting. So we'll see you around next time. Have a good one, guys.
See you.